Hey there, Calc folks. Back here with video kind of off the beaten path. I want to, in this video, I've been promising to give you some introductory videos to working in the Mathematica program. Um, just introducing you to this first video here today is just really going to introduce you to working with the program itself, some of the fundamental calculations you can do on it, your simple arithmetic, and then some of the fundamental operations, right, and how Mathematica handles all of that, the beginnings of the syntax for the language, folks, and introduce you to some of the common functions, like I said, or operations that Mathematica is familiar with. And then I'll follow this up with maybe another video or two where we'll get into declaring our own functions and looking at making tables and plots. And then even showing it as far as going in and starting to write some programming. And then getting into some of the calculus operations that we can see going on. And I do have another video I did prior to this that kind of picks up with vector valued functions for you Calc 2 or Calc 3 folks. I'll certainly continue those videos up in there, but in Calc 2, we may want to dip in and look at some of these ideas from Calculus 2, also using Mathematica. So this video is for both you Calc 1 and Calc 2 individuals. You Calc 1 folks, if you're up here watching this, it's all right to learn Mathematica also, but you certainly want to put in your time, right? And I say that because you do have to learn. You do have to learn calculus, folks, how to work within the field, and not always have to rely on a program like this. But certainly a program like this has its benefits, and we're going to see that. All right. So let me pull up my Mathematica here. Is this going to work? Probably not. No. I'm going to have to pull it up over here then, I guess. It's going to be that way for me today. That's perfectly all right. I can handle that. So here's Mathematica, folks. Again, I use Mathematica on the I use Mathematica. I actually own the program, right? It is available for free on the web. I believe the web address is lab.wolframcloud.com, if I'm not mistaken. And I do have given you a link in the class notes and in the Blackboard for this course, where I've listed out the link to the cloud version of Mathematica. But this is the paid version. But everything I do here in the paid version, you're able to do out there in the cloud. You just have to have cloud access, right? Be on the internet, in a sense. So, to begin with here in Mathematica, and I may have shown some of this in class already, but I'll go back through and refresh a little bit here and kind of think of starting first days with Mathematica. And Mathematica will do some rather fundamental arithmetic operations, right? If we maybe add a little bit of a title here, let's add a title of alt. Let's add a title of arithmetic on Mathematica. Let's look at doing a little arithmetic here. All right, on Mathematica. Right? One of the first things we might consider is that Mathematica can handle complex operations, folks. It can be it can handle here some really rather complex operations. Right? For example, right, as long as we put things in here in an appropriate order of operations, right, Mathematica will, I should say, follow an appropriate order of operations. For instance, we could have the quantity 2 plus 3 times the quantity negative 5 squared all divided by 6 minus 3 n quantity squared, plus 4, right? Or not equals, plus 4, right? Mathematica will go through and calculate that value for us as a fraction, right? This is 2 plus 3 times the quantity, negative 5 squared, negative 5 quantity squared, 5 being the squared, not the negative, right? But that is going to be divided by 3 and quantity squared, right? That's where the fractional form is going to come from. And then all multiplied by 3, added to 2, and 4 will give us our end result seen here, right? But Mathematica will follow through with those operations. And notice how I did get Mathematica to perform that operation. There are 2 ways to input and input. You can hold shift. As soon as you get to your line of input, right, this is going to be my input line here. As soon as you get to your line of input, if you hit shift, hold the shift, and press enter, Mathematica will enter a line of code. For each line that Mathematica takes as an entry, it will call this input 2. It's input 2 because input 1 was the first time I did that operation. The first time I inputted in here, right? That's the 3rd time I've done it, right? And I can do it again and again and again. This is the 4th time. Where you'll notice that each time I have run this line of Mathematica, this line of code in Mathematica, we've gotten an output, and this is the output. And notice Mathematica does label it as an output here, folks. The other thing that you might be able to see on my screen, I actually have to shrink down my window a little bit, is to show you that off on the right here, there are these cell brackets that form, that kind of define our cell. Overall, this is the entire cell that we've been working in. This is the title portion of the cell, whereas down below here we get into the inputs and outputs, where the first is the input and the second is the output. And each of these cells has a different type of behavior there. You can see I just collapsed the output for that particular input by clicking on its cell title there. There, notice looks like I deleted the entire cell, but I haven't. I've just packed it all away into this title, and I can click on that title and bring back that cell. Now, I don't know if this is true just in regular Mathematica or if this works on the cloud version. I do know there's titles in the cloud version. And the way that I do get a title cell is it's Alt, your number keys do different titles. Alt 6 was this title format, but if I was to do Alt 5, we would see something a little bigger. If I was to do Alt 4, we would see something a little bigger than that. Alt 3 even goes much grander than that and into black. Alt 2 is black and smaller. Alt 1, right, is really a grand title there, black and red. Well, red at that point and rather grand. I was at 6 originally. 7, right, is similar to 6 but a little smaller. 8, I like 8. 8, sorry. Yeah, gotta be careful there. 8, Alt 8. When you're in a title, we'll keep it on a title size. I gotta be careful there. Alt 9 will take us back, but once we kind of have a title declared, it looks like that it's gonna keep that declaration of the title. What I do note here is you may or not be able to see this in the recording, depending on how good the recording is. But if you have a input line in Mathematica highlighted and you hit Alt 8, right, it will highlight that entire cell of input as a gray color, which makes it nice to identify if you have multiple lines. A code having them all in one cell, it's easy to see that way. If you want to eliminate that and go back to the original coding, Alt 9, is it? No. Is it Alt 6? No, it's not Alt 6. Is it Alt? It has to be Alt 9. Alright, that's no good. Yeah, it's Alt 9. I'm sorry. It is Alt 9. I was able to get back to my original line of code here. Notice if I hit Alt 8, it looks just a little different because it does approach it as a bit of code, right, or a line of code there, folks. Right? So that's just playing around a little bit with cells and fonts and fundamental calculation here. Right? There are some more complex functions built into Mathematica. There are the trig functions, right? We might say here, let's give this a title. Let's call this common math functions. Right? You have your sine. Oh, let's see here. Okay, so there we go. There we go. Yes. You have the sine function, right? You can apply that to an x, or you can apply that to, for instance, pi, and we know the sine of pi is 0. You have the cosine function, right? You might apply that to something like pi over 4, and we know that's 1 over the root 2, right? You have the tangent function, right? We might look at the tangent of 0, right? And we see that that is indeed 0. Or maybe we have the cotangent function, right? We know the cotangent of, let's see here, let's go with -1, right? Is negative cotangent of 1. It really doesn't have a clear cotangent, right? But if we wanted to come up with a decimal approximate of it, we could wrap that in an n, and calculate it, and we could obtain a decimal approximation of that cotangent of -1 in value. Otherwise, Mathematica is going to give you back these as exact values, and in cases where that exact value is defined best as using the cotangent function, it will do so, as we've seen here in output 8. The function n, right? The function n can be applied to quantities to give the decimal approximation, and we can actually apply that function n to make larger decimals quantities by following the function we apply it with the number of decimal places we want. Right here I want 10 decimal places. I could also have that calculated out to 100 decimal places, right? And this is just the n function, right? I could calculate pi out to 1,000 decimal places using the n function. And you notice how Mathematica is applying these functions, folks. Mathematica applies its functions using what we call wrappers, right? What I have done here with pi in this previous statement, right? What I've done with pi is I have wrapped it in the approximation function. The brackets are used as wrappers, right? They are indicating that the quantity inside is being wrapped by this functional behavior that's found on the outside here. All right? Here we applied this numerical approximation wrapper to the cotangent inverse, or sorry, the cotangent of -1, right? And looked at its value out to 100 decimal places, right? Functions, folks, right? We are just taking the value pi and wrapping it in the sine function. Or taking pi over 4 as a quantity and wrapping it in the cosine function. Or taking 0 as a quantity and wrapping it in the tangent function. Or -1 wrapped in the cotangent, which is just negative cotangent 1 in exact terms, where to get the approximation, we can then come back and double wrap that -1. We could double wrap it in a numeric approximation, which is what we see here. All right. And the standard numeric approximation gives that typically out to like 5 or 6 significant digits, right, is what we might see. All right. What are some other common functions? There is the exponential function. For instance, if I took exp of 0, right, we should all know what 0 wrapped in exp is. This is e to the 0 power. This should give us the value of 1, right? Or if I was to give you the log of exp, then raised to the let's go with third power, right? If exp is e, right, and actually we could see that with, let's back this up. If I take exp of 1 then, that will be the value of e. We see that come out. Where then if I take and I run the log on that quantity, right, the log of exp is just the value of 1 itself. The log is a way of saying ln, natural logarithm, folks. The log statement is the natural logarithm. If you wanted a log of some other base, you would have to let's say you wanted the log base 2 of 4. Well, that would be the log of 4 divided by the log of 2, right? Notice here I would have to use the change of base formula. And what is going on with this result? Why didn't we calculate this? Can I simplify? I don't know if I want to bring up the simplify command that early. No. It should be change of base, right? And the answer should be 2. Well, I don't know why it's not working. I'll have to look into that. All right. I'll be doing a little change of base there. Let me get rid of that. Notice I just highlighted the cell and deleted. Right? Those are common functions, folks, and they're applied with that syntax of wrapping those quantities with brackets. All right. Some other quick things to show you. The percent sign always recalls the last input. You'll notice even though I deleted the last input, log of 4 divided by log of 2, the last output there, I was able to recall it using the percent sign. So if I was to do a series of math, let's say I was to do 2 plus 5, and to look at its result, then we know that's 7. But then I wanted to take 7 and square it. I could always just do percent squared and get 49. I could then take that quantity and add to it 6. I get 55. And then maybe take the square root. Now you can't see that on screen. Let me bring this up. I could then take the square root of that last input, 55. And it's going to say the square root of 55. Right? Where if I want to take a numerical approximation of that, I could say, well, what's n of that percent? And that gives me the numerical approximation of 7.4162. All right? Those are some common functions in Mathematica, folks. And you can see there I brought in the square root function. Right? How do we do square roots? You could use higher powers, right? And 1/2 power there, but also square root or fractional powers. But square root works. I got to figure out this. Log is natural logarithm. Exp is e function, right? E to the power of x. N is numerical approximations. You can see how you write in pi, right? Pi is put in there just as pi. Notice in Mathematica, commands, operations, functions, and other named items are always capitalized, right? They're always capitalized, right? All of your functions will always start with a capital letter. You'll notice here square root, SQRT, it does begin capitalized, all right? Even E, if you want to talk about E as a number, right? E is put in as capital, right? And what is E again? We could take a numerical approximation of it. Remember, E is about 2.718 in value, 2.71828. If we approximate it out to several decimal places. All right. So, folks, this is just some fundamental arithmetics in Mathematica. Some of the fundamental functions, right, and so forth. And I will tell you, Mathematica actually has a really good help window here. Let's see if I can get... Ooh, it's not going to let me open it up. But if we were to go underneath their help documentation, can I get this to... come up? Maybe I can. Let me see here real quick. Yes. Right. In the Wolfram Cloud, it would be a little magnifying glass up in your right-hand corner. You would see that would take you over to the help, and you could search through the help. If I wanted to look for pi, right? It says, yeah, pi. Pi is a built-in symbol. What's special about pi, right? It walks you through some information about pi. It gives you even some more further details. You can click into here. It tells you different ways to get pi to appear. What were some other things we did? We did sine, right? How would I do a sine? Right? Well, that's a built-in symbol, as well as the arc sine, right? We should be familiar with that. We could do a sine integral, whatever that means, or a Fourier sine transformation, some really advanced stuff, folks. But we can certainly see sine is one of the first items that pops up. Right? If we were interested, well, how did we do a square root? Right? Certainly you'll see that square root function come up as one of the very first options there. All right, respectively. So, there is a good help menu here when looking at different functions. And this is going to be very useful for us, folks. Because not only will it do simple functions like we've seen here, but there are some advanced functions that it certainly does. As you can see, there's something like, I think, like 3,000 functions, 4,000 functions built into Mathematica, if I'm not mistaken. Right? How many functions are in Mathematica? Maybe this is a question for Wolfram Alpha. Right? But I think there is quite a few. Certainly I get 6,578 pages on that. Right, folks? But certainly there are quite a few. But nonetheless, that is all just minutia. Anyway, but I did want to show you some of this fundamental arithmetic to begin with here, folks. Notice every once in a while, if you are working here and you get bogged down, you want to delete all your output, you certainly can do that with your cell menu. I don't know, that doesn't appear for you folks, but if you click up on cell, you can delete all your output. Underneath evaluation up at your top menus, I know you can't see that either here, folks, but it will bring up a drop down where you'll be able to quit the kernel. Right? Quitting the kernel is kind of like resetting your entire program, right? Resetting its memory. And I've just done that here. I've quit my kernel and reset my memory in a sense. All right. I think that's everything I wanted to give you here, fundamentally speaking. Let me just double check. I'm not going to save that. That's not worth saving. Let me open up. I know I had a quick little demo with some things in here. Intro to Mathematica. Introduce you to this. Fundamental calculations. Get all that right. A little bit more advanced. Square root, cube root. I could have shown you. You can take cube root of values. Right, get 3 back for the cube root of 27. You can put inputs in for trig measurements in degrees. You just have to write the word degree at the end, right? Or it can go in there in radian measurements in terms of the context of pi, right? And then we're going to get into some of these other fundamental cases in the next case. I did do logs and numeric approximation for y'all folks here. Expressions, relationships, and declared functions, that's a topic for down the line. So, yeah, I think that is good for this video. We're right at 25 minutes, and this is a good little introduction to Mathematica, folks. So I'll stop there. All right, I will then stop there. So, see you in the next video.